Hello, Tim Graves here again to take you through another little session on some of the stuff that you can do with Helidon in terms of creating microservices. Now, one of the things that you may have seen so far is that we had our status service running on the same server as we had our main service. Now that's fine, but you may well want to separate out some of the administration type of functionality from your core service functionality. Perhaps you've got a service, for example, let's say a metrics or a health service, and you only want that to be accessible from a certain set of network entities. So you want to restrict access effectively by controlling the ports in your firewalls. This is particularly useful if you're doing things like Kubernetes, where Kubernetes may well run things like metrics and data gathering on a separate service to other services, for example, what the process is actually doing. Now, Helidon makes this really, really easy for us. As you would expect, this is probably done by a config file. In this case, I'm going to show you the config file I'm using, which is the storefront config file, that basically specifies a server that by default runs on port 880, but it also runs an administrative port on port 9080. The bind address basically means it'll accept a request from anywhere sent to anything. We could, of course, have restricted that. And basically what we're doing here is we're specifying what the server looks like, and we're then saying that a couple of specific services, the metrics service and the health service, will sit on the admin port, not the main service port. Now, this is pretty easy to do here. We just really need to include that as part of our configuration file setup. So again, we're doing here is we're specifying the configuration file manually in terms of configuration file orders, but this could equally well be something that we would do using a configuration and a meta configuration file. So literally all you can see here, all we're doing is we're saying use the storefront network file. If it's not there, don't worry, and include it as part of those build processes. Okay, so let's just save that and we'll give our service a quick run. Now, you can see there's a couple of additional pieces of information here. You may not have noticed this before. Originally, we had the default channel that was running on port 880, but now we also have the admin channel, which is running on port 9080. Okay, so we can look in, or we will look at a little bit more detail about what we're going to put on each of these, because at the moment, although we do have the admin server, we haven't enabled any of the health or the metrics data. But this is how we would set that up. So it's really pretty easy to do this. Now, let's talk about one of the other elephants in the room, shall we say, which is how you would handle exceptions and errors. Okay, so the reality is code fails sometimes. It may be because there's a problem in the code. It may be because the code deliberately throws an error that it's expecting to be caught, as we saw in one of the earlier labs, where if you tried to make a reservation request, which was less than the minimum allowed request, it would generate an exception. The problem is that the Java-based exception system, which gives us lots of nice named exceptions that are really easy to track, doesn't directly map onto the HTTP-based system, which is basically around error codes. Now, there is a connection, but the question is, how do you bring those two together? So that's what we're going to look at now. Well, to start with, what we're going to do is we are going to deliberately configure the system so that it will generate an error. Okay, so what I'm going to do here is I'm going to set our stock manager to a value of null. Okay, you may have noticed that it had a dummy in there. That was just for test purposes so that we could do that without having a database behind the scenes. We'll be looking at how we do databases shortly. Okay, so we've now forced this to be null. So anytime we access the stock manager, we're going to expect to see a null pointer error. Let's just confirm that. So if we go and run our code, and we'll go and make a request. So let's go and access Okay, let's just go and reserve some stock. Boom, instant server error. Okay, if we look at this, we can scroll back and we will see that there is, in fact, a null pointer exception. Okay, if we go and have a look at the point of that code, you can see that we're trying to access the stock manager. As we would expect, there's a null pointer. But the problem we have is 500 isn't a particularly useful error message. Okay, it is an error message, but it doesn't explain in a lot of detail what the error message is. So what we're going to do is we're going to use an annotation that says, in the event of a problem, I want you to go and call this other piece of code. Now, what I'm going to do is, for now, I'm going to put it on the list stock method. Okay, and we're going to put this what's called a fallback annotation. Okay. Now, what this annotation does is it says, in the event of a failure, call the method failed list stock item. Okay. Now, that method is further down here. Okay. Vitally important to note, this must have exactly the same message signature. So you can see that our original class method returned a collection of item details and did not take any arguments. Our fallback mechanism also returns a collection of item details and does not take any arguments. And in this case, we're just basically converting it into a web exception, which is a 424 error, which is basically failed dependency. We're putting a little bit of it into little bit of text in there to say, yep, we can't connect to the error message, and then we're returning that call. Okay, so it's pretty easy to see how that would work. Now, what we're going to do, let's save that, and if we run it again, and now let's go and make a request to the list or stock endpoint. Come on. Okay, so we're going to make a call to the list or stock endpoint. Now you can see this time that although we had a null error, if we scroll down in the console here, you can see that our code did in fact generate a null error, as we would expect. The framework picked that error exception up and converted it into a failed dependency. Now, this works fine if you've only got a particular set of error codes or you only care about a fairly generic set of information. However, as you can see, there's no real easy way of finding out exactly what the error was, what the stack trace is, for example, where it was in the code. So you are kind of relying on log data as well. Now, the good news is that you are passing a method back and the calling code can look at that and say 424. Probably not a lot of point in making that request again quickly. It might work. Maybe I'll try it once more. But if I keep on getting it, I'm not going to retry that request. Now, what we can also do is there's another way that we can do this kind of processing. So if we have a look at the reserve stock method, what I'm going to do is I'm going to put a different annotation on here. Now, this annotation says go and call a method in a specific class. Okay, so if we go and have a look at that piece of code, the stock fallback handler, this is a somewhat more complex system. Okay, so it implements a fallback handler of type item details. Effectively, what we're doing to start with is we're building up a set of mappings of exceptions to effectively HTTP error codes. Okay, then if the error is encountered, the handle method will be called. Now notice this has again the same return type. Okay, so item details, it is what is returned when you try and reserve stock. It gives you the updated version, right? So effectively what will happen is the exception will be thrown, the Helidon framework will capture it, and then it will pass this to an instance of this class with the execution context. Now, I don't propose to go into all of the details of what this code does. I'm sure quite a lot of you will look at this and say this is truly horrible code, and you are probably right, because this is something I hacked together pretty quickly. But basically, what the code does is it tries to work out what the underlying method error exception was, map that onto the HTTP error code, and it will also, where appropriate, include things like the exception error messages, potentially a stack trace, the parameters that were passed into the call, and so on. So please go and have a look at this. It does a bit of nasty introspection and so on, but it does work. So let's go and run that. Okay, and if we now go back in, and we're going to try and make a request to reserve some stock. Okay, so let's call our reserve stock method. This, of course, is going to fail. We know that it's going to fail. You can see that the result we got back, yes, it says we're an error 500. It tells us, effectively null pointer, it's telling us that there was a problem processing the request. It tells us where that happened in the reserve stock item method. It tells us that the argument was an item request, which had this particular value, and there is an exception message. In this case, it's just saying there's no more detailed. Okay, so we've now got a lot more information as to what's happening. Now, obviously, you can change this however you want. You can put whatever systems you want in place to understand how that code works. Effectively, what you're doing is you're building up a mapping to say, in the event my code generates an exception, convert that into an HTTP error. Now, there are also mechanisms that will convert from HTTP numbers into exceptions. And that's going to be very useful, as we'll see later on when we look at how we handle what's called the REST client. Okay, now, other things that could go wrong. Okay, at the moment, when this code runs, if it tries to call an external service, it basically just sits there until that service responds, or until it's told that you can't access it. But what we might want to do is we might want to expand this to say, if you try and make a request and you don't get a response, let's say within 15 seconds, then I just want you to give up and generate an error so you're not blocking the whole time. Okay, so there we go. Effectively, we put a timeout. We're doing this in this case on the whole class rather than individual methods. We could have put it on individual methods. We're basically saying, if you don't get a response within 15 seconds, generate a timeout error. Okay. Now, we can't actually demo this because obviously we're currently showing and generating null errors, but we will have a look at how this might work in one of the later labs. So what we've just looked at here is how to handle the situation whereby you have an exception, how to handle the situation where you want to separate certain features from certain other features by network port, and how to write code to effectively convert a Java exception into an HTTP reception that can then be processed and handled using the HTTP methodology. So thank you for that. Instructions are coming up on how to get the template code, including the handler class, which you may want to look at. Please do not treat this as a particularly good quality code, but you might find something useful in there as an example. So what we're going to look at in the next video in this sequence is how you can start accessing databases. And we're going to do that using the Stock Manager microservice that we're going to start building. Thank you very much for your time and attention. What you've just seen is based on a lab which goes through effectively using Helidon to create microservices from a monolith piece of code. This lab is available to anybody on the internet. It's originally written to work in the Oracle Cloud, but you can take the source code from the Git repository and run it in your own environment. You can use a MySQL database or other databases if you want to. So what I'm going to do now is quickly show you how to get to the lab. That will include links to where you can download the original template source code and obviously the content of the lab itself. So in a web browser, if you go to bit.ly/go live labs, okay, and that will take you to the Oracle Live Labs starting page. Then search for using Helidon to create microservices from a monolith. Now that's going to return 2 lab options. The overall sequence of videos is based on the extended lab version, but if you don't want to do the extended stuff, you can just focus on the shorter version. You basically just click the launch button, and then if you want to run it on an Oracle trial, you can register for free trial environment. If you already have a free trial environment, you can then look at running it within that environment. You just basically click on that. You can then have access to the web page. Effectively, what you need to do, follow the instructions under getting started and set up your tenancy and set up for the Helidon Labs to get this working in the Oracle Cloud environment. Now, if you don't want to use the Oracle Cloud environment, then there are instructions on how to download the source code using in the setup for Helidon Labs section. You'll obviously need to make sure that you've got Java 11 on your laptop. You're going to need to make sure that you've got a suitable IDE and so on. If you want to use a database other than the Oracle database, you can do that, but you'll need to configure the database files so that you can ensure that it will work on the local database, and that's basically through the JDBC and JPA, JTA settings in the meta-inf folder. So thank you for that. Hopefully you will enjoy playing with that, and good luck.